Welcome back. We are still on physics mail and we are still on simple machines, part 2 of it. So far we have considered the concept of velocity ratio, and we have seen the velocity ratio of various machines. So right now we are going to move to the second objective in part 2 of simple machine, and that second objective is efficiency of a machine. So let's look at that. So efficiency of machines. Efficiency of machines. That's what we want to look at. Okay, I believe we have taken note of this, so let's begin from here. Let's wipe this. So let's begin from here. Efficiency of machines. Efficiency of machines. Okay. Now, what do we mean by efficiency of a machine? We know what we mean by something being efficient, very effective, efficient. That means it gives you what you want. That's when something is efficient. It works very fine when it's efficient. So a machine that works very fine is said to be efficient, but that's a layman definition. We are science students, we are physics people, so we will not just be defining efficiency in that way. We need to make it to look like physics, to add color to it. So let's make it to be physics. So we define efficiency. We say that efficiency of a machine is the ratio of the useful work output, or the work output, ratio of the work output to the work input of a machine. So the ratio of the work output to the work input in a machine is known as what? The efficiency of that machine. Now you need to actually apply effort for the machine to deliver a work. So by application of effort, you are trying to impute work into the machine. Then the machine now will do a work. You see that's the output. So the work done by the machine, the ratio of the work done by the machine to the work that you impute in the machine, that's what gives us the word efficiency of a machine. Remember, it must be the useful work done. The useful work done. So the useful work done. So the ratio of the useful work done by a machine to the work input to that particular machine gives us the word, the efficiency of a machine. Very beautiful. Very beautiful. So we can say that efficiency of a machine is work output over work input. That's the ratio. Now, efficiency can be expressed as percentage. So we can express efficiency of a machine. Efficiency of a machine as percentage, or in percentage. You can express it as percentage or in percentage. Let's say as percentage. You can express the efficiency of a machine as percentage. If that is the case now, what we need to do is just to multiply this by 100. So if we want to express it as percentage now, we want to express it as percentage, we are going to say that efficiency is work output over work input times 100/1. All right. If we represent efficiency with small e, let me use E to represent efficiency, and I use W sub 0 sub O as work output and W sub I as work input. That means efficiency E will be 100/1. So here we have said that work output, WO is work output, and then WI is work input, and then E is what? Efficiency. Now, efficiency can be expressed as percentage, can also be expressed as fraction, and can also be expressed in decimal. But it's important to note that the only time we will have to add this 100 in the expression is if the efficiency is in percentage. For example, if you are told that the efficiency of a machine is 0.75, then you are not going to, this 100 will not appear in the expression, except you first of all change this 0.75, which is in decimal, first of all change it to what? Percentage. But if you want to do calculation using this, that means the 100% here, this 100 will not appear in the expression. All you need to do is just to say work output or work input. Yeah. Because if you express this in percentage now, in decimal, as a fraction, you do this. So this 100 will now come over here. So take note of that. It's not when you are giving efficiency maybe as a fraction. You are told that the efficiency of a machine is maybe 2/5. And you now want to calculate, you still put 100 there. You will mess up. Seriously, you will mess up. So just take note of that. This 100 can only appear in this expression if the value of the efficiency is in percentage. All right. Now, something is very, very important. We have said in our last video, when we treated mechanical advantage, we said that frictional force affects machines, and frictional force affects efficiency of a machine. So the efficiency of a machine is not usually 100% because of what? Frictional force. Because part of the work input in the machine will be used in overcoming the what? The frictional force. So the work input will do two work. First of all, to give us work output, and also to overcome frictional force. So because of the presence of friction in machine parts, a machine will not have 100% efficiency. So if efficiency of a machine, the efficiency of a machine is not usually 100% due to friction. So friction reduces the efficiency of what? Of a machine. Friction reduces the efficiency of the machine. That means in every machine, work is done against friction. Work is done against friction. So when there is work input, part of the work input will go and do work against friction to overcome frictional force. Then the remaining will now do the actual work in the machine to give us the work output. So if WF is the work done against friction, then we can write that WI is equal to WO plus WF. So the work input is equal to the sum of the work output plus the work done against what? Friction. The work done against friction. Very important. Very important, because in some cases we will be given the work done against friction. And in order to get the work input before we start off our calculation, then we must be able to establish the work input. We must first of all add the work output and the work done against what? Against friction. So we have various expressions now. Various expressions. We are still going to come back before we start our calculations to look at all these expressions. Just be taking note of them. Just take note of them. All right. Now, since efficiency is work output over work input times this, we can also express this in terms of power. We know that power is work over time. So we can also say that efficiency is power output over power input. So we can also express efficiency as power output, the ratio of power output to power input. So note, efficiency of a machine can also be expressed in terms of power as follows. Efficiency, power output over power input. That's efficiency. So we can actually, in terms of percentage now, we have this. So efficiency E, we can write efficiency E as PO over PI times 100 over 1. So we have that. Oh, so far so good. Now, I believe you are enjoying the meal. Gradually we are feeding you. It's very, very important that you master the concept of machine. It will be very helpful. Now the next thing we need to look at is how do we connect efficiency, velocity ratio, and mechanical advantage. These three important terms in machine, they have a connection. So we are going to see the connection. You are free to take water, even as I'm taking my own water now. Just take a little water to digest what we have done so far. All right, water is good. Now let's see the formula connecting the efficiency of a machine, the mechanical advantage of a machine, and also the velocity ratio of a machine. Quickly, let's look at that. Oh, so we say formula connecting efficiency, mechanical advantage, and velocity ratio. What connects them? These three are very, very important concepts in the study of machine. Very important concept. So, all right, let's remember the expression we gave. We say that efficiency is work output over work input times 100 over 1. Very beautiful. Okay. Now, work output is the work done by the load. Yes, that's work done on the load. Then work input is the work done as a result of application of the effort. So, and we know that work done is force times what? Distance. Yeah, the dot product of force and distance will give us the work done. So it means that work output will give me the load, L. You remember the symbol of load is L times the distance moved by the load, right? So work output will actually give us LY. Then the work input will give us work done by the effort, which is the effort times distance moved by the effort. So that's EX. So I can use this and this to replace these two. And if I do that, I will have that efficiency E is LY over EX times 100 over 1. Okay, recall L over E. You recall that L over E is mechanical advantage and X over Y is velocity ratio. Thus, Y over X will be 1 over velocity ratio. That's turning it. If X over Y is velocity ratio, that means Y over X, if I turn this, will be the reciprocal of the velocity ratio. So based on this, I have L over E. I can replace L over E with MA and replace Y over X with 1 over VR. So we can do this. Let's first of all separate them in such a way that it will be easy for us to do so. We can say efficiency is L over E times Y over X times 100 over 1. So this now, we have written it in alternative form, which is this. L over E times Y over S. If you still multiply this, you have Ly. You multiply this, we have ES. So we did not change anything. So what is L over E? L over E, load over effort, is mechanical advantage. Times what is Y over X? Y over X is 1 over VR, because X over Y is VR. But here we have Y over X. If I want to get Y over X, it means I need to turn this. And if I'm turning this, I'm also turning this. That's why it is 1 over VR. So times 1 over VR times 100 over 1. So if we simplify this further, we have MA over VR times 100 over 1. That's my efficiency. So mechanical advantage over velocity ratio will give us the efficiency when you multiply it by 100. It will now be the excuse me, the efficiency expressed in percentage. All right, so far so good. I believe that you are enjoying the meal. Yeah, that's our business. Our business is to make sure that you enjoy the meal. So we have another expression. Now before we go, before we just end this particular section of simple machine, because in our next video we are going to generate all these expressions, we're going to write them out and then begin to carry out calculations. So our next video will be all about calculations on simple machine. Very important. That's what we'll focus our attention on in our next video. So let's say this. Is it possible for the efficiency of a machine to be 100%? We have said that actually the efficiency of a machine will not be 100% because of friction. But if the efficiency of a machine becomes 100%, such a machine, we call it ideal machine. A machine whose efficiency is 100%. And such a machine is a frictionless machine. It means we don't have any frictional force acting on that machine. Well, we don't know whether it's possible. Maybe we'll see such machine in heaven. We don't know yet. So, but when we have a machine, if a machine has 100% efficiency, then that machine is said to be what? An ideal machine. And such a machine is a frictionless what? Machine. That means the frictional force is negligible, or we say there is no friction. And if that happens in every ideal machine, that is a frictionless machine. In an ideal machine, the mechanical advantage is equal to the velocity ratio. Please take note of that. You can write it down. In an ideal machine, in an ideal machine, in an ideal machine, in a frictionless machine, in a frictionless machine. So note, in an ideal machine. Okay, first let's say an ideal machine is a machine whose efficiency, or a machine that has 100% efficiency, or that is 100% efficient. Such a machine is frictionless. In other words, when we say it's frictionless, the frictional force is negligible. And then for every ideal machine, so for every ideal machine, mechanical advantage is equal to the velocity ratio. So for every ideal machine, mechanical advantage is equal to the velocity ratio. Why? That's so beautiful. Very beautiful. So far so good. I believe that you have enjoyed our meal till this point. If there is any part that did not digest, please don't vomit it. Just tell us. Leave a comment for us. We have a way of adding something that will make it to digest. We have physics enzyme. You know why you did not digest it? Because there are some enzymes that are supposed to act on that particular meal. That's why it did not digest. So if there is anyone that did not digest, don't vomit it. Just tell us the part that did not digest, and we'll give you the enzyme that will just react with that part, and you'll see it digested. Don't mind me. This is where we are going to end our second part of simple meshing. In our third part, we are going to start looking at calculations involving simple meshing. But first, before we start the calculation on that day, we just list the various expressions, formula that we need for our calculation. Keep watching our video. Keep following us both on YouTube and also on our Facebook. Visit our Facebook page on a daily basis. There is a mail there for you. Yeah, definitely. We have a mail that will keep you healthy, that will keep you sound as far as sciences and mathematics. These two are concerned. Thank you for following us, and may God bless you abundantly. I'm still your friend and brother, Engineer Ike. I love you.